In this video, we'll start Chapter 11, the first part of it, and Chapter 11 is Univariate Analysis. And what we're going to focus on in this chapter is organizing and preparing material data for analysis, computer programs, and then also displaying data in graphs, tables, and charts. So let's talk about the types of statistics. We have descriptive statistics, which are used to summarize and describe the cases, the data on the cases in a study. And then we have inferential, which is where we take a sample and we try to make an inference to a larger population based on information from our sample. Univariate statistics deal with a single variable. And multivariate statistics deal with two or more variables, and in particular bivariate statistics we'll talk about later in the semester with regression analysis. So different software for data management and analysis. Obviously in this class we use Minitab. Some other common programs are SPSS and SAS. Spreadsheets can also be used particularly to manage data and also to do some analysis. And then we have programs called database managers like Access, Oracle. The college uses PeopleSoft. And there's also geographic information systems which are very helpful for displaying data on a map. So what's a spreadsheet? A spreadsheet's a matrix of cells that are formed by rows and columns. And the spreadsheet program shows a form on which the data can be entered. We can have different widths and column lengths, and we can have numerical text. We have graphical data that can go into a spreadsheet. And a program like Excel has many built-in functions, so we don't have to actually write an equation in order to do a calculation. But we can create formulas if we want to manipulate the data in the cells. And these are useful for small data sets. And we can use these also to input data into statistical software programs as you do with Minitab. We take the counting data in an Excel program and we use that and move it into Minitab. So here's an example of your textbook data set as you're familiar with in the Excel form. Now a database management system is useful for larger amounts of data, and it allows users to store them and enter and store, and their use of forms. A program like Access it creates data entry forms. And we can sort and report large amounts of data. Again, the same kinds of things: text, numbers, labels, formats, formulas. A relational database is a database with two or more files with common variables or fields. And that allows us to store different information in different locations. So for instance, at the college, we use a program called PeopleSoft, and we have a student database which contains all the information on the student enrollment. We also have an employee database, which can be linked to the student database, for instance, by the instructor's information, because the instructor would be in both locations. And that allows new data to be entered to the existing database without re-entering those common variables. And in that case, we also need a data dictionary. And you know, with your textbook data set, we have a data dictionary that explains all the data items, where they came from, any codes that are used, labels. And I mentioned the GIS information systems. These are really nice systems. They're a special type of relational database, and we allow the information to be stored, or displayed rather, geographically. Property appraiser data, crime statistics, and there's also the ability to do analytical mapping to show the values and distributions of different variables across the graph. Pushing the wrong button, sorry, gone the wrong way. And the relationship of the variables to locations can be seen. So for instance, we could overlay crime data with unemployment data and then visually see the relationship. Those regions with high unemployment might be expected to have higher crime rates. Here's one system, a community crime map. I'm not going to pull it up, but you can use this link here. And it allows you to see within a particular community, and I put in, this is Pinellas, I put in St. Petersburg Gibbs campus, and it shows me all different kinds of crimes there that I selected when I went to create the map. And you have a lot of great information that you can show here. Okay, tabular displaying of data allows us to list each case along with the value of the variables measured. And table 11.2 from your book shows three variables. It has a case number, which is really an identifier variable, the county, the cause, and the severity, and they're looking at some kinds of injuries, I guess. Three variables displayed on 20 cases. It's difficult to really see what's going on when we simply look at a tabular display. We'd like to organize the data somehow. And this might mean by creating a frequency distribution is one way to do it. So here we're looking at fire rates for cities in southeastern United States, and we're looking now, we've grouped them now by rate. So 49 cities have a fire rate between 0 and 199. 112 have a rate between 4 and 599. Again, I can see much more about the distribution of the information than a simple tabular listing of all the individual cases. Relative frequencies can be shown here, so this is going back to that tabular listing we showed before where we have the counties here and we're looking at the frequency of the injuries. And we see the percents over here. Again, percents or relative frequencies are actually a nice way to visualize the data also. We see that almost half were coming from one county. Class intervals are the boundary for each category, and the class width is the distance from the lower bound of one to the lower bound of the next. Now, this only applies with numerical data and not with categorical data. Cumulative frequency distribution shows the cumulative frequencies. So up through 39, we've accounted for 23% of the data in this particular group of employees' ages. So some guidelines for constructing data tables. You want to make sure you have a title, obviously, and this applies to charts, graphs, and figures. You want to label all the variables in the variable categories. You want to define any terms that might be open to interpretation in a footnote below the table. You want to put the source of the data should be indicated again in a footnote section. Visual presentation can illustrate points more clearly than verbal descriptions. Tables, graphs, and charts also help the analyst see what is in the data as well as to present for an audience. Again, you want to fully label the display, and display should be discussed. Independent variable across the column label and the with label, and categories across the top of the table, and the dependent are the row variables. Totals should be given at the bottom of each column. Okay, a few kinds of graphs to end up this section. Bar graph. Most people have seen a bar graph. Very useful display for categorical data. Shows a variable along one axis and the frequencies, or perhaps the relative frequencies, on the other axis. And the length or the height of the bar indicates the number of cases in each category. We always have the same width bars and they don't touch. And the vertical or horizontal presentation just depends on the number of categories. It's really just a preference. So here's two different ones. Here's one shown this way, where we've got the frequencies along the vertical axis and then the categories along the horizontal. This is the opposite way. We've got the frequencies along the vertical and the categories along vertical, frequencies along the horizontal. A bar graph with bars in decreasing order is called a Pareto chart, also a nice graphical display. A histogram is similar to a bar graph, but this is what we use for plotting interval or ratio level variables, in other words, quantitative variables. We can use frequencies or relative frequencies. The width represents a range of values. The columns adjoin one another since we have a continuous range of numbers. Sorry, I've got a tickle in my throat today. So here's an example of a histogram. A pie chart, similar to a bar graph, shows 100% of the data. The size of the slices show the portion of the data. And things are labeled. There's an example from Minitab. Same data in a bar graph and a pie chart. Line graph or frequency polygon, again, shows interval or ratio level data. And it's like a histogram, but instead of bars, we put a dot in the middle of each bar at the height at which the bar is, and then connect the dots. And in this case, let's go back for a second. This one's not smoothed out because we don't have very many cases. As the number of cases increases, look at the frequencies here, it smooths out. And a time series is where we graph horizontally the time variable and frequencies along the vertical axis. We can use any kinds of time variable, month, year, week, whatever. And we look at rates here. So here we're looking at property tax levies over time. We can see some nice distributions and talk about what's going on. So in summary, went over in this section computer software and then also some presentations for data, including frequency distributions and some graphical displays. And next week we'll continue in Chapter 11 with more topics in univariate analysis.